This call is now being recorded.
What I'm trying to achieve over here is I want to download a couple of images from the Sentinel group of satellites, and specifically Sentinel 2. I want to then do a quick NDVI within QGIS. I'm not uh, I'm not going to go into details of the NDVI and things like that because I'm no expert at this. But this is just to kind of show as to how simple it is if you follow uh, very simple guidelines and instructions. Now, this is how the NDVI is defined mathematically on Wikipedia. And there's a lot of background over here. So in case anybody wants to read this, this is a wonderful resource to go through. I'll go to that later. First, how to procure the Sentinel images. Now there are a number of options here. One is this. One second. Did I close that tab? Yeah. So one is this, which is a Sentinel Hub. Pretty decent. I tried this earlier. They have a dashboard and everything. They have a very good service. You can track as to how much usage is there and things like that. But it's a monthly account, this thing trial account, which is ending in 2 days. So initially I thought maybe it's just a free account, which it is not. So, okay. The other option is this, which is Sentinel Sat. With Sentinel Sat, this is a Python package, and with this, the issue that I had was that this unfortunately did not run from my IPython notebooks, and so I don't know. Maybe I didn't read through enough. It did run in the terminal. It definitely did run in the terminal, and the images were downloaded. So that is one. Now, the other option is that you directly go and download them from this Copernicus Open Access Hub. So, and somewhere, I don't know, initially, I think it was with this particular package that the URL which was constructed did not have the DHUS in the end or something to that effect. So maybe there was some old reference and stuff like that. But yeah, that's one thing that we kind of need to note in case we are using the Python API or we are downloading through a script and not doing it non-manually and stuff like that. Now, let's say we were to do a manual download, and the region that I'm looking at is basically this Bharatpur area, because I'm aware there is a wildlife sanctuary there, a bird sanctuary. And to understand as to in which months of the year the wildlife sanctuary and the areas around it would be more greener, so to say, and would have more vegetation versus not, is what I'm trying to achieve with this quick NDVI. I'll refresh this page and I'll try and go through the entire thing again. In case I do get stuck or something to that effect, I'll resort to what I've already done here. So I've already kind of done this. Let's see. Now, depending on your system configuration and what, how much is your bandwidth of the internet and stuff like that, things might differ slightly. You might have to spend slightly more time or slightly less time depending on. Now you choose the polygon or the rectangle. In my case, I'm choosing the rectangle. I'm pretty much focused on this area. Uh, while I've done that, the 100 kilometer by 100 kilometer image that will get downloaded, or the entire data that will get downloaded would be for this larger area. So it will be uh, the let's say the eastern boundary will be somewhere around Agra, and left is, I think, this Kherli or something to this effect. So let's just see that. So all I've done is I've just created a rectangle over here, and I've gone and now I'm clicking on the advanced search. You can expand that. So ingestion date is okay. So it will be sorted out by ingestion date, which means as to when the data set was basically uploaded to mm, the Sci-Hub, Sentinel, this thing, the cloud data processing structure or whatever it is. Uh, Now that is one, and in descending order, which is perfectly fine. So that is what we want. And the sensing period. So there are two, three different dates that I looked at, or periods that I looked at. So one was July 2020. The other one was December 2019. So December to January 2020. Uh, Presuming that there would be a marked difference in the vegetation index, or marked difference within the visible vegetation. And depending on the visible vegetation, there is a certain reflectance that happens of the infrared and the red spectrum, and that is what gets picked up, and that is how we basically end up calculating whether a particular region is having enough greenery or not in a particular season, and things like that. So all that detail is here. So this is what it is. Now standing water will not be as green as the vegetation. The soil will not be as green as the vegetation. We get to see that in a minute. And let's say we were to choose a period which is between, say, 1st of July to, say, 7th of July. So that beginning of July 2020, and just choose the mission Sentinel and do nothing else. Absolutely nothing else is required, and just go ahead and click on the search. And of course, you need to log in. So my login is saved. Otherwise, you will have to log in. It will say, okay, fine, logged in, and again click on search. Once you can see that, yeah, it's there. You click on search, and so it'll take about a minute or two to search, and that's about it. So what I've done is I've gone ahead and saved my data already here. Pretty simple. There is so now what happens is that the downloaded file is a zip file, and within that there is the safe format. What I'll do is I have already gone ahead and created a GitHub repo of my own, in which there are quite detailed notes that I have. Let me just yeah, so this is the one. And in the README itself, so the safe is basically the standard archive format for Europe. So uh, this is probably a format which has been decided upon by the folks at the Copernicus project and the Sentinel. So I think it is not only for Sentinel but also for Landsat and others. The format is probably the same, and this is a wonderful resource. If you read through this resource, you will get to see. And this is how, if you were to run the tree command and you were to be in that directory, So this is how you'll end up viewing your entire structure of let me try and do that. uh, yeah, so this is how you get to see the entire structure. And what we need to focus on right now is the granule, and within the granule the image data. And then of course there is this R10M and R20M, R60M. So within this we will again focus on these, which is the R10M, and specifically the band 2 and the band 8. Or is it the 4 and the 8? I think it is the 4 and the 8. Let me just check. Yeah, it is the 4 and the 8. So the 4 being the infrared and 8 being the near infrared. So that is what we'll focus on. And once you have the data set down and you stored it in this, say it comes down to your downloads or wherever, you just end up copying the zip file over here and you unzip the file. So you uncompress the compressed file and go into the granule, and this is what you're looking at. And this structure itself shows you that this is 2020, so that's the date, and the month is January, and it's around 30th of January, and sorry, not around, but exactly 30th of January that this data was collected by. And the satellite is Sentinel's 2B. So there are two of them which are there, which is Sentinel 2A and Sentinel 2B. And then it says the MSI L2A. So what exactly is MSI? MSI is multiple spectral imager, if I am not wrong. So like you can go and see here. I have again somewhere here. 1 second. I also listed out a definition of it somewhere. Yeah, but yeah. So that is multispectral instrument data. Okay. Uh, so yeah. So getting back to that directory. So within this image data, if we go here, this is what we get to see, and we are now looking at 4 and 8. So what you could also do is you could right click on this and say open, or even double click. So if you have QGIS installed, it'll end up opening up QGIS. What I did was I went into the layers, an add layer, add raster layer, went into that particular directory and added that. So those are already here, so I need not do that again. What is done after that is I ended up renaming these band 4s to red and band 8s to near infrared. And I followed one tutorial on YouTube itself, and there's an Australian person who's done that, and he's done it quite well. So he's done it, obviously he's got a lot of experience with this, so he's done it real fast and quick. There are certain other tutorials which are there which really didn't they take too much time to get to the point of it, so yeah, couldn't follow much there. So now we have 4 of these. So what we can see is we have 4 of them. This is the red for 3rd July, this is the red for 3rd January, this is the near infrared for 30th January, sorry, and this is for 3rd July. Now what we'll end up doing is we will end up going into this raster menu, and from here we'll choose the raster calculator, which is the top this thing available, in the drop down. We will go back to the wiki page and we will refer to the formula which is there, which is NIR minus red divided by NIR plus red, and that is what we'll input over here. So let's say NIR I need to choose for the 1 second. Yeah, for the, oh, why is this showing in a, yeah. So yeah, so this is 30th January. So this is what I'm choosing. How I've chosen it is by double clicking on it, minus the same dates red band, which is this right above it. Then close the brackets, divided by, again just add both of them. So this plus, and this is it. So once this is done, I need to choose output layer. So output layer basically means where my raster image, which will be the end result of my NDVI, will get stored. So let's say I were to choose this, and I've already created both of them. So yeah, I could just create a dummy. Let's say demo, and say save, and that's about it. Just click on OK at the bottom over here. You need to check that it is GeoTIFF. The output CRS is by default, I presume, the same, which is the one for the images which are being used over here. But I haven't really checked that. So maybe we can check that later on. And that's about it. So just say OK. And this might take slightly more time on certain systems because of maybe CPU it uses, or I don't know if even if it uses the GPU. I'm not really sure. But that's about it. And here we have, it says output NDVI demo. So this one is exactly similar to what I have earlier over here. So let me just kind of push that up, which is this. Yeah, so move to top, and this one. Now what I get over here is minus 0.98, so which is almost the same as -1. So I can just go here, go to the properties, and within the properties for the render type, I end up choosing single band pseudo color. Why pseudo color? Because this is not the actual color, the RGB image which comes from the satellite. So it is the NDVI that we've created out of red and infrared bands. The actual color or the natural color RGB would be the red band, the green band, and the blue band. Now over here, the minimum can be -1, and the reason, as mentioned in that tutorial that I followed on YouTube itself, was that we want to standardize this so that we can compare maybe the NDVI that we end up creating for different regions. So if we do that and in a certain standardized manner, uh, so that will help. Now this over here, we want it to be spectral. So some folks are using blue, greens, and stuff like that. I want it to be spectral because when I used spectral, what I ended up seeing was that the regions which have a water body, or regions which have absolutely no vegetation at all, end up being red, which is okay. So just for our visual this thing, to keep it distinct, that seems to be okay. And apply and okay, and that's about it. Now there should not be much of a difference between this, which is already displayed, which is this output underscore NDVI underscore Jan 2020, and the one which we've just created. So let's see. I move to top, and that's about it. So you really can't make out the difference. Now, to see how this is different from the July one, and this is what is visible right now on the screen is actually the Agra airport. So this is not the Bharatpur Wildlife Sanctuary. I'll just scroll to that. I'll just change that. But if you look at the airport also, and you say July move to top, so this is the difference. You see in July versus January, July is much more, mm, uh, all the regions are quite similar. So which means there is probably not, and I'm saying probably because I will further have to check this, but probably not so much of a difference in vegetation and in the areas. Um, so that is one. The second is here when we move this to top, you can see that there is quite a distinct difference on this particular area, which is on the left side. And then these are farms outside. So this is obviously farmland. And so the airport itself probably in January had some growth over here, which was not the same as the growth over here, right? And then this was much more greener, which is similar to the farmlands out here. And this is obviously this is the population in the sense these are habited areas which over here are almost around zero or even slightly on the minus side. And again, this particular region, which is say a small orangish blob over here, is definitely on the negative side. And just to see what this is, and actually look at the uh, actual map, so the political map, so to say, we end up looking at OpenStreetMap. And yes, so this is definitely a water body over here. And because it's a water body, it is showing in a negative this thing on the January one. So let's look at it again. Yeah, so it's definitely a water body and it's negative over here. Similarly, we could end up looking at the coloration of the river. So if you look at the river, the farmland and even some of this is green. So right next to the river bank, there is much more green in comparison to the river. So the water is definitely in the negative over here. If you look at July, then again, July is much more. I don't know. Maybe I did not do the right calculation because July's values, the initial values were different from the values of January, and it's got a very very a broad spectrum. So I really can't say, but yes, there is definitely a difference which is there. So I'll have to look into this again. Now let's zoom out of here and look into uh, the Bharatpur Wildlife Sanctuary. So this is the one. So it's difficult to make out otherwise, but within the July one, it is much more greener. Mm, I'm not sure why this could be the case because I presume most of this area is mostly water and less vegetation in comparison to what is happening outside in the neighboring areas. But if in the neighboring areas, let's say the farmland or the grassland has got less vegetation in July, then this makes sense. So let's look at January now. This is January. This is definitely a distinct water body over here, the one which is in red. Uh, there is farmland and grassland around, um, which is much more greener. This is probably a village or a clearing. Again, a village or a clearing. So let's look at the street map. Yeah, so it's a village. This is also a village. So habited areas, those are slightly on the orangish side in the January one, or maybe not really orange, but just yellowish. And this internal area is also not as green as the farmland, even though it is, mm, because it's got water bodies. If somebody who's been to Bharatpur, you'll realize that it's got water bodies and trees, and not necessarily much of grassland and growth. But if you were to let's say we were to look at this particular water body, and this so you got a lot of difference over here, and you were to look at the July one, you see it retains that distinction. But again, I'm not very sure, so maybe this is slightly off the this thing. And of course you can again see water bodies here in the middle, so where my pointer is right now. um, and very distinctly you can see that in the January one. So it's orangish, uh, definitely water bodies here right next to the road. This is probably the road or the track, walking tracks. Right. So this is how a very basic NDVI can be done. And within this here, this is again, I don't know what water body this is, but it is quite a distinct one. And this is right next to the river in Agra. And let's look at the map. Yeah. So it is again some Sarovar bird WS. Yeah. So again, some kind of bird sanctuary or this thing, and a water body for sure. Uh, right. So for some reason, the open street map over here. Oh, okay. No. Yeah. So that's about it. And thanks.